Okay, so everyone is talking about AI agents, right? These things that can automate super complex tasks. The hype is absolutely massive. But how do we actually build them so they're smart, effective, and this is the big one, safe? Well, it turns out there's a really clear framework for this, and today we're going to break it all down. You know, when we think about powerful AI, our minds immediately jump to the Hollywood version, right? These incredible super agents that can do literally anything. Until, you know what happens, they tend to go a little bit rogue. It's great for a movie plot, but in the real world, that's a catastrophic design flaw we have to avoid at all costs. And that really gets to the core of what we're talking about today. The Hollywood myth is all about this one single all-powerful super agent, but the smarter reality, the one we actually need to be building, is a team of specialized agents, all collaborating. It's about a fundamental shift in how we think, moving away from a lone genius and towards a super coordinated crew. So why is that whole lone genius model so dangerous? Well, it really boils down to two fundamental flaws in the design. Two things we absolutely have to steer clear of if we want to build AI systems that are safe and reliable. Flaw number one is something called super agency. This is what happens when we give an AI agent way too much freedom. We just give it a big, vague goal and say, go figure it out, with basically no guardrails. And that, well, that leads to unpredictable actions. And honestly, that's where things can go really wrong. And the second major flaw is overprivilege. Now, this is a classic problem in cybersecurity, but with AI, it becomes even more critical. We're talking about giving an agent permission to do everything, read, write, delete, update, across systems it doesn't even need for its specific job. It's like giving someone the keys to the entire building when all they need to do is water a plant in one office. It's just a recipe for disaster. Okay, so if the super agent is the problem, what's the solution? We need a totally different way of thinking about this. It's an approach built on collaboration, not on a single all-powerful command. I love this analogy from the source material. Think about a road construction project. You don't have one guy who paves the asphalt, directs traffic, and files the city permits, right? No way. You have a specialized team. That is exactly how we need to build our AI. The goal is to create a smart team where each agent has its actions and its access minimized to only what it needs to do its one job. Engineers have a term for this, high cohesion. It just means one task, one tool. The real power of the system doesn't come from one agent. It comes from how all these specialists work together. So, how do we actually organize this team of specialists? We need a framework, something practical. And that brings us to the real heart of this whole approach, the agent matrix. It is a simple but, believe me, incredibly powerful tool for designing these systems. So, here's the big question, right? How do we actually categorize this team? We know they're not all created equal, so how do we draw the lines between them and figure out which rules apply to which agents? And the answer is actually pretty simple. But it's also really elegant. We can map out every single agent along two key dimensions. First, its capability. Basically, how much complex reasoning can it do? And second, its risk. What's the potential for damage if this thing messes up? Let's just build this matrix out piece by piece. Okay, we start in the safest corner, low risk and low capability. A perfect example is a simple search tool for your internal company wiki. It can't do very much and it really can't cause any harm. Simple. Next, let's move up. We're at low risk but high capability. Think of an agent that helps edit internal documents to match a style guide. It's highly capable, it's actually rewriting stuff, but because it's all internal, the risk is still pretty low. All right, now we cross the line into more serious territory. High risk but low capability. A good example here is a finance data extractor. Its capability is low, it just reads and summarizes data, but it's accessing sensitive financial info, so the risk is automatically high. And finally, we get to the quadrant that demands the most respect, high risk and high capability. Think about an accounts payable system that actually initiates payments. It has to reason about invoices, it's dealing with real money. That is a whole lot of capability and a whole lot of risk. Okay, so now that we've categorized the what, the different types of agents, we need to talk about the how. What are the specific rules of behavior for these agents based on where they land on our matrix? And this really shows the fundamental difference in how they act. The high-capability agents, they're what we call non-deterministic. That just means they have to reason, they problem-solve, they figure out their own path as they go. On the other hand, the low-capability agents are totally predetermined. They just follow a fixed, predictable script of actions. They don't think, they just do what they're told. Now, this difference in behavior has huge implications for security. Because those high-capability agents are unpredictable, they need to be what we call ephemeral. That means they're created for a task and then they're destroyed. Their access to anything has to be dynamic, given just in time for one action and then taken away. But the low-capability agents, they can be persistent. They can stick around with a static API key because we know exactly what they're going to do. Their behavior is predictable and contained.
So let's zoom back in on that high-risk side of the matrix, because this is where the controls are absolutely critical. For a high-risk, low-capability agent like that finance extractor, you need extra business controls. We're talking about strict logging, alerts, that kind of stuff. But for the high-risk, high-capability agent like that payment system, there is one crucial, non-negotiable rule. You absolutely must have a human in the loop. Before that agent can take a high-stakes action, a person has to see it, and a person has to approve it, period.
So this all brings us to the final takeaway, the big question you should ask yourself. As you think about building or using AI, ask this. Are you designing a single, all-powerful, and incredibly risky super agent? Or are you building a smart, safe, and collaborative super team? Because as we've just seen, building a team of specialists isn't just the safer way to go, it's the smarter one. And that simple difference could change everything.